Hi, and welcome to Rails tutorial. Today's topic would be on weight and normal force. Please like, share, subscribe, and comment on this YouTube channel. Today's topic will be about weight and normal force. First, let's talk about weight. From the description we have here, it says the weight of an object is the gravitational force exerted on it by Earth. Now let's reverse back a bit. Sometimes people describe weight as mass. They are two different things. So mass is the measure of the quantity of matter that comprises of on an object. What does that entail? A chair, for example, a chair on its own, a chair has its mass. A chair is an object, but it has its own mass. So, for you to determine the weight of the chair, it depends on the location of the chair. That's how you can determine the weight of the chair. So the weight is determined by the gravitational force exerted on that object. But the mass, it will always be constant. So if the mass of a chair, let's say this is a chair, it depends on the location. The force of gravity applied here determines the weight of the chair. That's why we have it here. It says an object's mass. An object mass does not change with location. The weight depends on the location. So here we have weight is a force because we're talking about it's a force because something has to be applied to the mass. Gravitational force has to be applied to the mass for it to determine the weight. So we have force is equals to mass times acceleration. So the weight, that is Fw, weight will be mass times gravitational force, or Fg, force of gravity, will be weight mass times gravitational force. And this diagram explains it. This is an object here. The weight of the mass of the object is the same thing as it is. This is the mass of the object, it doesn't change. But the force of the object depends on the hand here pushing the object forward. So the speed of the motion of the acceleration depends on the weight of the mass. Because we say mass is equals to, and force is equals to mass times acceleration. It's an object and the acceleration. So if this object is 500, if this object, let's assume this object is 500. Let's assume the object M is equals to 500 of 500 kilogram, and the acceleration A is equals to 10 meters per second square. So the force applied here would be 5,000 Newton. But if the acceleration was less, if the acceleration was 1 meters per second, then the force would be 500 Newton. So just put it at the back of our head that force changes depending on the location. Why? Let's look at an example. This example says, what is the mass of an object that weighs 500 Newton? The mass of an object is an object here. The object weighs, what is weight? 500 Newton. And we know that force of weight is equals to mass times acceleration. And we are already told that the force of weight is 500 Newton. We don't know the mass, but the acceleration, since it's of the earth, acceleration will be gravity, that will be 10 meters per second. So meters per second square times the mass. So for us to find the mass would be 500 divided by 10, and that will give us 50 kilogram. So the mass of the object is 50 kilogram. That's the answer to this. Okay? A person weighs 150 pounds. Given that a person weighs 150 pounds, given that a pound is a unit of weight equals to 4.45 Newton, what is this person's mass? So this is just simple calculations. Now we are told that this person weighs 150 pounds. The first thing is to convert these pounds to Newton. And here, in 1 pound is 4.45 Newton. So we'll say, we divide this by 4.45, 4.45 Newton. And when you make your calculations, it will be about 7.5 Newton. Now we have the weight in Newton. Now calculating what is this person's mass, like what we had before. Since force of weight is equals to mass times gravitational force, that is acceleration. Therefore, we'll have it as Newton is equals to 10 meters times the mass. So for us to get the mass will be equals to 667.5 over 10, which would be 66.75 kilogram. Okay, that will be the person's mass. Okay, let's look further to other ones. So now we want to look at normal force. Normal force is the contact force exerted on the surface that acts perpendicular to the surface of an object resting on it. So we know we say weight depends on the gravitational force exerted on it. So if an object like this object we have here from this image here, the mass is the mass. This mass is resting on this table. This gravitational force is directly under this table. So it's perpendicular. It's just under the table, hitting up to the center of the object. So the normal force is in line with the gravitational force. So when we have an object, just as this table indicates, an object is here on a straight line, on a flat surface on a surface, when an object is on a flat surface, the force applied, gravitational force applied is easier to determine as perpendicular. It's just directly under the object. So the normal force is usually perpendicular to it. So it's just perpendicular to the object. In this case, we call this a normal force. So like this definition says, a normal force is a contact force exerted by a surface that acts perpendicular. Mark that, perpendicular to the surface of an object resting on it, and counteracting the object's weight. The normal force is denoted as Fn, as this normal force. Because I wanted to remark this as perpendicular because as we keep moving, we have other types of forces. An object whose mass is 2 kilograms rests on a table. This is an object. Find the magnitude of the normal force exerted by the table. Find the magnitude of the normal force exerted by the table. So we have it, just the same thing. Normal force is Fn is equals to mass times gravity. Because it's just perpendicular to the surface of the earth, nothing changes it. Then we have to find the Fn. The mass is 2 kilograms. Then the gravitational force is 10 meters per second square. So the Fn is just mass times gravity. So I should always remember that for normal force is just perpendicular to the surface. Okay. Let's look at other examples. Okay. So with this example, I'm introducing frictional force a bit. But first, let's start up with the first box. Because this example says, draw a free body diagram for each of the following situations. Now, the first situation, the body is at rest. This object is at rest. It is this box. And once an object is at rest, the center of the object is always the center of gravity. It's always like the center of gravity. So this is the center of this object. And the gravity applied on it is down this way. Then the normal force is up this way. So this lower one is the Fn, the normal force. Then this under one is the Fg. And the next one, this box, a force has been, acceleration has been applied on it. A force has been applied on it because right now, this object, the stick mass foot kicks the box. So the box tends to move. So in this case, this is the center of gravity. This is the center of gravity. Now, the object we still have here as the force of, so we have here as the force of G. Then up here as a normal force, Fn, right? But now because the box is being kicked towards this direction, so here the force applied is here. and it is called the force applied. The force applied, the force of the foot, the force applied goes in this direction, in this other direction. If the stick man was kicking the box in the opposite direction, the force applied would be going towards the opposite direction. Then in box C says the box slides at a constant velocity across the level ground. And remember, when we hear constant velocity, the acceleration is what? Zero. So even if it slides at constant velocity, since the acceleration is zero, that means there's no movement, right? So therefore, here, the box, the frictional force, the gravitational force lies down that way. Then here's the normal force. And here's the normal force. Okay. Then now box D, the box slide through a rough path and slow due to frictional force. So in frictional force, the object does not move on a smooth path, on a straight path. It can be an inclined path, it can be, but not a straight path. It's not smooth. The normal force object is just on a flat surface. So the difference between this is just like when you are going down, when you go hiking, you're going down the hill. That hill is not smooth, it is rocky. But when you're walking on a straight, flat road, it's just a flat road. So right now, this box is sliding down through a rough patch. So here, and it's sliding down through this direction because that is the direction of that is the sign. When we see this sign, no, that is the direction it's driving to. So right now, the gravitational force is always at the center. The gravitational force is always at the center of the object. Then the normal force will still be perpendicular because the object is still stays flat. It's not an inclined form. This is the normal force, Fn. But now, instead of calling the force applied force, we'll call it the force of friction because it's a rough surface, so there's a friction. So here, excuse me, we have the Ff. That's the frictional force applied to the object. It's going towards the direction of this sign, the force of friction. All right. So in this other description here, the object in this other sign, the object is slanted. The box slide up a ramp with friction. So in this case, the box is sliding up a ramp with friction. So this is how the box. This sign shows the direction of the friction. Then, as I mentioned earlier, the force of gravity is always at the center of the object. So the force of gravity will still be here. Now the normal force is no longer perpendicular. So the normal force slants this way. It's no longer perpendicular because the object is not perpendicular to because the object is not on a flat surface anymore. The object is slanted, so the normal force is no longer on a straight path. Then the same thing to the next box too. Let me take a minute and see if you can identify the normal force, the gravitational force, and the friction force on this line F. I'm just gonna give you just 1 minute. And you can put your answers on the comment section. Okay, so now let's work it out together now. Let's see your answers. Where will be the frictional force? What will be the direction of the frictional force? Frictional force will be directed in this direction as F of F. Force of gravity, gravitational force will be always at the center. And this is the center of gravity, center of the object. So remember, the frictional force is when an object is in a rough patch, not on a flat surface. The normal force is when an object is on a flat surface. Okay, let's look at more example. Okay, now let's look at this example. The example says an object, a can of paint with a mass of 6 kilogram hangs from the rope. If the can is to be pulled up to the rooftop with the acceleration of 1 meters per second, 1 meters per second square, what must the tension be in the rope? So we have the mass here, the weight of the mass coming down here. This is the weight of the mass. There is a tension pulling it up. Force of tension, Ft. Now we're looking for what is the tension in the rope. We're looking for the tension in this rope here that takes the tension in this rope here that pulls the object up. So to get this, to get this force of tension will be equals to the force of the weight plus mass times acceleration. And we know that force of the weight is equals to mass times gravity, that means plus mass times acceleration. Since these masses are similar, m and m, so we'll say m bracket g plus a. Then the mass here is 6. Gravity g is 10. Acceleration was already given as 1 plus 1. So we have the answer would be 66. Because 6 times 10 plus 1 is 66, right? That is 6 times 11. 6 times 11, that is equals to 66 Newton. So because we're looking for the tension of the rope, so when the tension force in the rope Ft, which is upwards, and the weight, which is downwards, we're going to call this positive direction because they're in different direction. So then they're in different directions, so it's going to be positive direction. And this applies to the second law of Newton that says net force is equals to ma. It is mass times acceleration. So we just want to add the force applied on the weight plus the force applied for the plus the force of the object. as how we get the tension force. So we always note that when we are solving this, so many keynotes to take. So let me recall it again. For normal force, the component of the contact force is perpendicular to the surface. Frictional force is parallel to the surface. Weight changes based on the location. The mass is constant, does not affected by the location. All right. Okay, so today we've come to the end of today's class, this topic, weight and normal force. Please like, share, comment, and subscribe to this YouTube channel. I'll see you in the next lesson. The next lesson will be about frictional force. Bye.